All right, in this video, we're going to talk about particle motion. So typically we've been dealing with functions y equals f of x, where x could be all kinds of different sets or subsets of the real numbers. So we're going to take a similar approach using derivatives and mins, maxes, all that, but we're going to look at functions that depend on time. So most of the time, these will be position functions, where you have a particle that's moving either in a horizontal direction, so it could be moving along the x-axis, or it could be moving in a vertical direction, so along the y-axis. So position dependent on time. So that's going to change the domain because time is not going to be negative for us. We can start off at time 0 and move forward, but that's it. So as I mentioned, most of the time we are going to have particles that are moving in a horizontal direction. So for example, at some point in time, p of some time value could be a 3. That means its location is 3 on the x-axis. And at some other point in time, the position could be -5. So you have a particle that's moving left, right, could be moving all over the place. So keep in mind that the derivative of a position function is velocity. Well, what's that going to tell us? Well, that's going to tell us the direction in which our particle is moving. We know that it's moving horizontally, but we don't always know if it's moving forward or backward. If we look at our velocity, then if it's positive, that means that the derivative of our position is positive, meaning increasing. That would mean that we are moving to the right. And if our derivative of our position, which is velocity, is negative, then we would be moving to the left. If our derivative is 0, that means we're not moving anywhere. Our particle is at rest. So it could be moving left, right, and all of a sudden stop, and then keep going in one direction or go backwards. Now, one thing that we're going to see is something called displacement. So you can think of this as really just where I ended relative to where I began. So for example, suppose that p of 0 is a 1. So that means that my particle is starting off at the location of 1. And let's say that p of 4 is -7. So hypothetical, let's say that these time values are in seconds. So my particle could have been moving to the right and stopped and then moved to the left. It could have been moving only to the left. But all I know is when I started off at 1, I ended off at -7. So my displacement would just be the difference from where I started to where I ended up. It's a distance from my endpoint to my very starting point. So you typically are just going to find the difference and take the absolute value because this is, by definition, a distance, and distance is always positive. Displacement is a little bit different than distance traveled. So for distance traveled, what we would have to do is find all of the time values when our particle stopped, find how much it's traveled then, and then any other times where it stopped, and then total all of those together. So for example, my particle could have started off at 1, moved to the right maybe 3 units, and then stopped, and then moved all the way back to -7. I would have to add all of those distances together. So total distance traveled is, you think of that as the sum of distances between stopping points. So it's almost like a couple of different displacements if you want to think of each time window when you're stopping and starting. One other thing to keep in mind is PVA. So if I have that position function to find its velocity, I take the derivative. If I have the velocity function to find the acceleration of that thing, I take the derivative of that. So this is going to tie into concavity, mins and maxes. We can find the maximum distance from the origin that we've traveled using the first derivative test. We can find the maximum velocity by doing the first derivative test with our velocity function. All kinds of things that are going to tie into what we've already been talking about with derivatives. That should pretty much be it and get you started on those questions on Schoology.